Hello everyone, and welcome to this tutorial for basic Redshift volumetric lighting in Cinema 4D. So we'll be covering basic Redshift volumetric scattering as well as some height fog too. For this tutorial, I have a pretty simple scene. A street, some buildings, a car, two spotlights coming out of there. We've got some area lights, like for the street lights. I've got a softbox area light. And we've also got a Redshift physical sun and physical sky. So we're going to start with just the softbox light. And step by step, we're going to go through Redshift scattering and the volume lighting. We're going to set up the camera, go over to the Redshift render view and start an IPR. For now, we're not going to use bucket rendering, just the regular progressive rendering. So, we're going to enable our softbox light. So to use volumetric scattering effects with Redshift, we're going to go to the Redshift menu. We're going to go to Objects, and we're going to create a Redshift environment. So now you see we've got some volumetric scattering. So how is this light set up? If we go to the Redshift area light menu and go to the Volume tab, you're going to see two options, Contribution Scale and Samples. By default, Contribution Scale is set to 0, so you will not get any volumetric lighting by default with Redshift lights. So you have to increase the contribution scale. And so once you do that, you start getting some volumetric scattering, as long as you've got your Redshift environment. So if we've got some noise from our volumetric light in a bucket render, there's a couple of things we can do to clean that up. We can go to our render settings and increase the unified samples for Redshift. Or we can increase the local samples just for this light under the Volume tab. So if we increase the local volume samples, you'll see that we get a much better result. And it's very quick at rendering still. Okay, now let's take a look at the Redshift environment settings. So what do we see here? We've got a General tab. We've got some fog settings, some ray contribution scale settings, and an environment alpha replace setting. Today we don't need this, so the replace alpha should be enabled. So step by step, in general settings, we've got a tint option. This is a global tint for all of the volumetric lighting. It does not include fog, so it's just for volumetric lights. So if we change this color, let's try a yellow. So now we can see our yellow volumetric lighting. We can try something like violet and get that. By default, this is set to a white color. So the scattering value. This is going to define how strong your scattering effect is in your scene. Higher values are going to generate a much stronger scattering effect. So if you want to increase your volumetric scattering, we just increase this value. So if you just keep increasing that, you're going to get a fully white screen. And if we bring it back down, we're going to start to see some more information again. So this is controlling the scattering effect for every single light in the scene. So for this tutorial, we're going to use 0.1. So let's talk about attenuation. This controls both the strength of the fog and the amount at which lights get attenuated or their scattering effect is weakened as it goes through the space. So a higher number is going to result in stronger fog effects. So if we go into the fog emission and set the color to a green, we're not going to see anything at first, but if I increase the attenuation, now we're seeing the volumetric lights being lessened, but the fog is starting to come in a lot stronger. Again, if we increase to the maximum, we're not able to see our volumetric light anymore, but we can still see the fog. So for the moment, let's set the attenuation to 0. we don't need fog right now. So now on to phase. Phase basically controls the directionality and how the volume scattering is going to bounce around inside of the scene. So at default, with a phase of 0, it means the volumetric lighting is bouncing around in all directions at the same quantity. So if we set the phase to anything above 0, you're going to start getting a forward scattering effect, meaning the scattering rays are going to start going towards the camera. So as we increase this, it's starting to become more intense towards the camera. So conversely, if we bring the phase value down below 0, now it's starting to bias far away from the camera. So now, as we see, it's starting to only be visible back behind the car. So we've still got volumetric lighting, but it's not being distributed equally through the scene. So for this tutorial, we're just going to set that to 0. Next, let's talk about fog settings. Emission is going to be the color of the fog. And, so we're not getting anything because we set our attenuation to 0. So we'll actually set it to 0.1. So if we go to our middle camera and take a look and see what we've got here, we've got the camera exposure compensation enabled. And the reason for that is if we are using a photographic exposure node on our camera, then this should be enabled. If we're using the Redshift camera tag, then this should be enabled. So now let's take a look at the height setting. So by default at 0, we're just going to get fog everywhere. If we set it to something other than 0, then we're going to start getting fog at the specific height that we've set. So right now at 50, it's only showing up at the ground. If we increase it, we raise the height fog or we lower it. The horizon blur setting is going to be more easily visible at the far distance camera. So now we see at the horizon, the fog isn't, the transition isn't very blurred. And if we increase it, we're going to make that transition a lot smoother on the horizon line. So if I decrease this value, then the transition is going to get a lot tighter. So for this tutorial, we're going to use 0.1 again. So now let's move on. We're going back to the medium camera, and we're going to take a look at the use transform option for the fog. By default, this is enabled, but we can manually transform the fog and control which direction the fog is coming from and all kinds of stuff. So let's disable that. So we have ground point and ground normals as our options. So within that, we've got these 3 parameters for ground point and ground normals. So we've got a X parameter, a Y parameter, and a Z parameter. And that's the same for the ground normals. So as you can see right now, the ground normal is set to 1. And the ground point, if we increase that or decrease it, we start seeing different changes. If we change the ground normal to -1, then now we've reversed it. And so we're getting the fog in the opposite direction, up in the air. So we can also do a side-to-side value. So if we set the X ground normal, and let's play around with our values and figure it out. Let's see. Let's go to the far camera to get a better idea of what's going on here. Oh, let's use a -1 ground normal. Okay, that's better. So yeah, now we've got this wall of fog, and it's pretty cool. We can change the Z as well, and so now we've got a different direction for the volume fog, and just control where it starts and stops. So for this tutorial, we're not going to use any fog, so we're just going to set the attenuation back to 0 so we get rid of our fog for this scene. So Up next, let's talk about ray contribution scales for the volume lighting. So if we go back to our near camera, and let's look at the camera scale. If it's set to 1, then we can see the volumetric lighting through the camera. If we decrease it to 0, we can't see any. So if you start slowly increasing that, we're increasing the intensity of the volumetric light that's visible through the camera. The reflection contribution scale, you're not going to see anything now, but if we change our material to have some reflections, then we can start to see our volume fog in the reflections. So if we go back to the environment and start changing that, if we set it to 0, then all of a sudden we can't see any reflections of our actual volumetric lighting. We're still seeing the specular reflection, but not a reflection of the volume fog itself. So, global illumination, GI. By default, this is set to 0, so we're not getting any bounce lighting from the volume scattering. So even with the GI contribution scale set to 1, we're not seeing anything in this scene. That's because GI is currently turned off in the Redshift render settings, so we have to turn that on. We'll set it to brute force. So now we can see the volumetric scattering is actually adding to the global illumination in this scene. But now it's a lot noisier. So if we want to reduce the noise from GI, currently we're using brute force global illumination, so we're going to want to include or increase the number of rays for the brute force GI. And we're going to set that to 128, and it becomes a lot more clear. Still need to go a little higher probably, so let's try 256. So now it's taking a little longer to render. So for this tutorial, we're not going to use any GI contribution from the volume scattering, and that's just for the sake of progressive rendering speed for this tutorial. So just to recap on a couple of different ways to optimize the volume samples, we can do it locally on the light, or we can do it in the Redshift render settings and do it globally with the sampling, the unified sampling maximum. And another way is we can go into the sampling override section and override the samples for the entire scene on a per light or on a global light or global volume basis. And so these are all different methods to control the sampling and noise in the scene. But the fastest way and the most efficient way is going to be to do it locally on the individual light. So if we change those samples again locally for the volume, it's going to be more efficient. All right, back to our Redshift environment. Let's cover the last contribution scale, the environment fog. So let's go to the faraway camera. Let's increase the attenuation so we can see our fog again. Let's get some ground fog back by resetting those transforms. So now, if we decrease our environment fog contribution, now we're only getting fog around our volumetric light. And if I increase it, we start getting it everywhere. So yeah, we're not going to use it though for this tutorial. Let's set our attenuation back to 0 and head back to the medium camera. So let's go on to some of our other lights. So what do we got? We've got the softbox light with the volume parameters. It's just a white colored light with an intensity multiplier of 5. It's set to visible, and right now it's only got 16 samples. Why don't we just increase that up to 64? What next? Let's take a look at the street lights. We're using the cloner for 3 different street lights. So the area light for each of these street lights, we've got the temperature set to 3500 with an intensity of 500. And we're actually using a lamp mesh. This is a light mesh, and it is visible and bidirectional. So now we'll head back to the middle camera and enable these lights. So now we've got these warm street lights in our scene. We've also got some text in the back of our scene. It says Redshift, and this is an area light as well. The color for the light is set to red, and we've got the intensity at 10, and it is also a mesh light, so we've added that text geometry. And this is also visible and bidirectional with samples set to 64. So now let's enable this one. And we've still only got volumes from that softbox. So if we want all of these lights to have some volumetric contribution, then we have to go to each light and increase the volume contribution scale for them. So let's try 0.1 on our street lights. So wow, that is pretty intense. So let's reduce that. There's a couple of ways. We can go to the Redshift environment and reduce our global scattering value, or we can go back to our streetlight lights and only control those individually, and instead of 0.1, we'll try 0.01. So that's already a huge improvement. We've still got volume lighting from our softbox, but now the streetlights look a lot better. So let's go back to the text light. Let's try 0.01 for that text light as well. So we've got a little bit of volume light from our text now too. We've also got a telephone, and inside of there we've got another colored area light. It's a blue colored light with an intensity of 100, and we're going to set it to visible, and the samples are set to 64. Now let's set its volume contribution scale to 0.1. Nothing happened. Oh yeah, we got to enable it. There we go. All right. That looks really cool. So if we just want to increase the volume contribution for this light, we'll go to the volume contribution scale for this light, and let's just try setting it to 1. So all of our other lights stay the same, but the telephone light has increased dramatically. Let's use 0.1 and set it back to that. So now let's move on to our car's spotlights, the headlights. So now we've got some neat illumination from these headlights, but no volume. So we'll go back to the volume contribution scale and set it to 0.1. So there we go. We've got some volume contribution. How about we use 0.01 or 0.05? There we go. That's looking nice. So the spotlight parameters, the temperature is set to 6500. It has a very high intensity multiplier. It's like 250,000. We've got our cone angle set to 55 and our fall off angle set to 20. So now we've got a really nice looking clean picture with a bunch of volume lights, and it still renders really quick. So if we want to use the physical sun and sky, let's try disabling all my lights, and we'll go to the sun object and sky object and enable both of those. So somewhere up there we've got our sun, but we don't have any volume contribution. So we'll select our redshift sun, and we'll go to the volume contribution scale there as well, and let's try 0.1. This is too much because the sun is just so powerful. So now let's try 0.01. That's starting to look nicer. Still really intense, but you start to see what we're going for here. So we've got some noise, so let's increase our volume samples. That's making it nice and clean. So if we'd also like to add some GI contribution to this scene, we're going to have to change a couple settings. So we'll go to our Redshift environment and go to increase our global illumination contribution scale. We'll have to turn global illumination back on in the Redshift render settings. Let's set it to brute force, and there we go. Now we're starting to get a whole lot of bounce lighting from that sun volume contribution. All right. So this concludes the tutorial. If you like this tutorial, please subscribe to this channel for more. And thanks for watching and listening. See you next time.